So let's get into what data is first of all. So the term data is used to describe raw, unprocessed facts. So data itself has no meaning. An example of data would be 7, 34, 2, 21. Now we don't know what this list means. For all we know, this could be a list of random numbers. So it has no meaning, and therefore this would be an example of data. So if there's one thing that you need to remember, data is raw, unprocessed facts. Okay? So I'll give you a few seconds to copy that if you'd like. And you guys can just let me know when you're finished. Okay, perfect. Everyone else got it? Gonna move on in a few seconds. Okay, awesome. So let's go on to information now. So information is processed data. So unlike data, information actually has meaning. So examples of information would be Marcus is 7 years old, Catherine is 34 years old, Sage is 2 years old, and Fred is 21 years old. So we actually know what those numbers mean now. They're an age for each of these people. So that's the difference between data and information. Okay? So I'll give you a minute to copy again. So does everyone have that? Okay. You guys don't have to call me Miss, You can call me Makeba. It's fine. Mm-hmm. Yes, please. Okay, so I'm going to move on to the next slide now. We can get into information processing. So information processing is the use of computers to process data and turn it into information. Information processing takes place when a machine or processor interacts with the real world and acts on the inputs it receives. So an example of information processing would be an electric kettle using a thermostat to know when the water inside is boiling so it can switch off. So it takes that external stimulus, the heat of the water, to see if it's at boiling temperature so it can switch the kettle off. Again, just let me know whenever you guys are finished copying. Alrighty, I'm gonna give the others a few more seconds. Okay, now I'm gonna move on to the next slide if everyone's finished. Okay. So, moving on, information processing is only valuable if the information can be stored and quickly, accurately, and efficiently retrieved, and cannot be changed accidentally. So, the four basic stages of information processing are input, processing, storage, and output. You're gonna need to remember those stages. Alrighty. Gonna give the others 10 more seconds. Okay, and let's move on. So any questions so far? Anything you'd like me to go over? Anything you'd like me to clarify? Okay. Anyone else? Okay. Alrighty, so now we can move on to forms of information processing. So first we have commercial data processing, industrial data processing, control systems, and scientific data processing. We're going to go through each of these individually. So first let's start with commercial data processing. So this is the use of computers in businesses to automate or perform administrative tasks. So these tasks would include things like calculating payroll, recording and tracking customers' orders, processing sale transactions, preparing and sending invoices to customers, making payments for goods and services, keeping track of income and expenditure, making budgets, sending correspondences, designing packaging and advertising, or security. I know it's a long list, but it's always good to remember some of these things. So I'm going to give you a minute to copy those. So does everyone have this copied? Okay, great. So again, 10 more seconds. Okay, so let's move on to industrial data processing. So this is the use of computers to carry out all of the tasks involved in commercial data processing, as well as controlling the processes used to manufacture products using control systems, which we'll talk about next, using CAD or computer-aided design to design products, using CAE or computer-aided engineering, and CAM or computer-aided manufacturing to develop and test products. Alrighty. Give the others a few more seconds just in case. Okay, and now we can move on to control systems. So this is the use of computers to control machinery automatically. Some examples of this include using computers to manufacture chemicals or package goods in a factory, using robots to manufacture goods, that would be things like cars, using computers to control signaling systems like those on railways, using computers to control transport vehicles like autopilot, and using computers to control electronic equipment in the home, so things like washing machines. So for washing machines, you just put them on a specific program, let's say whites, and it will go through all of the instructions that it already has to wash white clothing. So it's automated, you just set it, and it goes on its own. Okay, are we done copying? Okay, perfect. So now we're going to get into the types of control systems. So there's two main types of control systems. The first one is automation systems, and the second would be process control systems. We're going to dive further into both of those. First, we're going to look at automation systems. So these are used to carry out simple tasks automatically without human involvement. So an example of this would be a task like a washing machine program. As we spoke about before, you just set it to whatever program you'd like to use, and it will just carry out those instructions. So once it's switched on, it follows a set of predetermined instructions to the end of the task. So you turn it on, and it just goes until the end of the list of instructions. Okay, perfect. Giving the others 10 more seconds, sorry. Okay, so let's move on now to process control systems. So these are used for more complex operations. So while automation systems are used for simple tasks, process control systems are used for more complex operations. So these are constantly updating their course of action. An example of this would be in manufacturing actions being changed by sensors. So data is captured automatically using sensors, which can measure things like temperature, humidity, light, sound, movement, and pressure. There's another slide on these systems, so this isn't everything. So again, I'm going to give you a minute to copy those. Okay, do we all have this copied? Okay, giving everyone a few more seconds to finish up. Okay, so let's finish off process control systems. So they convert the measurement that is sent in by the signals into the sensor, into electronic signals, which they then send to the processor. That's meant to say to the processor. My O key isn't working very well. Those signals can either be sent as a steady stream or they can be sent in intervals. Software in the controller processes the data from the sensors and determines what action to take next. It then sends the instructions to other devices like monitors or switches, which are part of the controlled machine. So the full process, the sensors would send in their measurements, their input, and those measurements would then be converted to electronic signals, which would be sent to the processor, either in steady stream or in intervals. And then software in the processor, in the controller, would process the data from the sensors and determine what action it needs to take next. And then that information is sent to all the monitors or the switches or anything else which needs to be used that are part of the controlled machine. Alrighty, a few more seconds to finish up. Okay, so next we'll move on to scientific data processing. So this is the use of computers to collect data during experiments. Sensors are used to capture data over a specified period of time. The data collected is used to make connections and observations to aid the experimental process. So statistical methods are used to analyze figures collected, and the results are displayed in charts and graphs. So that was the last type of information processing that we're going to do. Does everyone have that? Okay. Just a few more seconds. Finish up anything you need to. I'm just going to give you a few more seconds to finish up anything that you need to. Okay? And then we can move on to information retrieval. So information retrieval is the process of searching data on a computer to find the relevant information. So to ensure information retrieval is efficient, the data should be accurate, up to date, structured in a way that makes searching for specific information possible, and stored in a suitable storage medium. Alright, are you guys done copying? Alrighty. Okay, so the last thing we're going to look at today is information management. So information management is the task that ensures all data is input accurately, stored correctly, retrieved easily, and output in a way that provides useful information. And that's it. That's information management. Are you guys finished copying that? Alrighty, perfect. So, any questions for the day? Anything that was unclear? Okay. Okay, perfect. What about you, Ash? Okay, that's great. That's great to hear. So, it is almost 4, so now we're going to move on to our self-study questions for this week. I'm going to be here a few minutes after 4. I'm going to stay here so you guys can copy these. And I encourage you to do them for next week. Again, you don't have to, but I would encourage you to do them. Whenever you guys are finished copying that, you're free to go. Just enjoy the rest of your day and stay safe.